guys, welcome back to my channel. So in this video we are solving the past midterm of Concordia University, the midterm 1, and this is the part 2 video. I have already solved question 1, 2, and we are continuing with question 3 over here and 4. So if you want to check the previous questions, the part 1, I will provide the link in the description below, so do check that out. Alright, so let's continue with this problem now. So we have 3b to solve now. We solved 3a in here, and this is the answer to 3a. Okay, so now in here we are finding 3b, which says find the directional derivative of f at the point 1, 1 in the direction of this vector. Okay, so if you go check out my playlist of Cal 3, you guys can see that I've already explained you guys how to find the directional derivative of a given vector, directional derivative of a function at a point when you are given a vector and also when you are given an angle. So if you want to know how, in here I'll be solving this problem, but if you want to know how even when you're given the angle, then do check out my other video. Alright, so here when you're given a vector, so this is the formula that you're going to be using to find the directional derivative of f. So first you're going to take the gradient and then the gradient of the function, and you're going to dot product it with the u, and u here is the unit vector. Okay, so u that you see over here, u is the unit vector, and I guess you guys know how to find the unit vector. If you don't know, and let me provide the formula to that as well. So the unit vector, you find it as, you take the vector itself and then you divide it by the norm of the vector, and that's how you get the unit vector. Okay, so let's go ahead and calculate the unit vector first. So what is the vector given to us? So the vector given to us is -1 I hat, -2 j hat. Okay, so we have the vector as -1 and -2, right? Because it was like -I plus -2j, right? So this thing it was in the form of ij, and I wrote it in the form of vector, so I don't need to write the ij component. Okay, so this is our vector itself. Okay, so we are calculating for the unit vector, so we took the vector itself. Now we need to divide it by the norm of it. And how do we find the norm? We're simply going to square each component, right? And then square root the whole thing. So that is gonna be 5, square root of 5. So we're gonna write it at the bottom, square root of 5. So this, then your unit vector turns out to be -1 over square root of 5 and -2 over square root of 5. Okay, so this is your unit vector that you need in order to find the gradient, directional derivative. So now let's go ahead and calculate for the gradient. So we're finding the gradient of the function. So the gradient of function is nothing but simply f of x, f of y, and f of z. The function partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. So what is the function given to us? So the function that we have here is e to the xy squared. Okay, so we're gonna write, so we have our function as e to the xy squared. And first of all, we are finding the partial derivative of f with respect to x, which we can also write as f of x. So what is f of x? So here we are taking the derivative with respect to x, which means all the other variables are constant, which means y and z are constants. Okay, so we are differentiating only this one. So like I explained in the previous problem in the 3a, here we are solving for 3b, how to take the derivative of this one. So the derivative of this one, you can simply take the derivative just like this. For example, if you have something like this, how do you take the derivative of this one, right? So the derivative of this thing, it's going to be the same thing, e to the 2x but then you need to multiply by the inside function as well. It's a change, okay? And the inside function is e to the 2x, and what's the derivative of 2x? It's only 2, right? So this is the answer to this one, the derivative of e to the 2x. So similarly, you're going to solve this. So here you are differentiating with respect to x, and y and z are constant. So then the derivative of this one is going to be same thing again, and then times the inside function, and the inside function is the, okay, yeah, so it's the, so where I was, so yeah, so it's the inside function that you see over here. So oops, okay, so it's the same thing, and then multiply by the inside. So xy squared, and what's the derivative of xy squared? Considering we're only differentiating x, so the derivative of x is 1, so y squared is going to stay over there since it's a constant. Okay, so we can neatly write it as y squared e to the xy squared. Okay, so this is f of x. Now what is f of y now? F of y, e to the xy squared, we're differentiating only with respect to y. So here in this case, x and z are treated as constants. Okay, now we need to multiply by this inside function and differentiating only y. Okay, so we're differentiating only y. The derivative of y is 2y, and x is a constant, so it's going to stay over there. So this is going to be 2yx e to the xy squared. Okay, next, f of z. Okay, so we are finding f of z. So here x and y are constant, and we're differentiating only z. So here in the question itself, we only have x and y. There's no z. That means this whole thing is a constant, and the derivative of constant is 0. So f of z is 0. Okay, so we can write our gradient f of x, f of y, f of z. So our gradient turns out to be f of x, which is y squared e to the xy squared, and then f of y, which is 2yx e to the xy squared, and f of z, which is 0, so we don't need to write it. Okay, so this is our gradient. Now we need to evaluate this gradient at the given point. Okay, and then we can go ahead and dot product with the unit vector. So let's evaluate the gradient with the given point. And what is the given point to us? It is 1, 1. Okay, so the point that we're given is 1, 1. So let's evaluate this point with this gradient. So we're gonna be putting 1 inside this, where x is 1 and y is 1. So here, putting y as a 1, so it's gonna give you 1, and then e to the 1, 1, so that's only e. Okay, and here what do we have? We have 2, 1, 1, 1, so that's gonna be e, 2e. So when you evaluate this, so this is what it gives you, gradient as e and 2e. So now we can finally dot product it with our unit vector in order to obtain the directional. Was it again? The directional derivative, yeah. Okay, so let's go ahead and dot product this thing with the unit vector in order to obtain the derivative, the directional derivative. So we have this e2e dot product it with the unit vector. So what do we have our unit vector? So we have unit vector as -1 over square root of 5 dot product at -2 over square root of 5. So you guys remember how to use the dot product. So here we have I hat times I hat, G hat times G hat. This is how we do it. We multiply the I with the I and J with the J, right? Because I wrote it in this form, we have a decimal, a comma in between, but this can be also written as in this form, okay? So it's the same thing. So that's why we're doing the dot product like this. Okay, so when you do this, so it's -e over square root of 5, and here you have -4e square root of 5, and it should be a plus in the middle because we're doing the dot product. Okay, so now, So you are left with negative e over square root of 5 to negative 4e square root of 5. So that's 1e negative 4e, so that's going to be negative 5e over square root of 5, and this is the directional derivative. Okay, so this is the final answer to this question. Let's go ahead and do the last problem now of this midterm. Alright guys, so we're finally solving the last problem of this question of this midterm. So here we're given a function and we need to compute the curl of the function in part A, and in the part B you need to find the divergence of the vector field. Okay, so if you go over my channel, you can find a video as curl and divergence with trick. Here I showed you guys how, this is the curl equation. This is how you calculate the curl, and you need to memorize this equation, or if it's really hard for you to memorize this equation, then I have provided a trick for you guys to memorize this equation. So do watch this video out to know that trick. Okay, so let's go ahead and move to our problem. I'm not going to be showing the trick in here. You'll actually have to visit this video. The link to this video will be shown here at the I button. So do click at the I button and watch this video for the trick. Alright, so let's go ahead and calculate the curl of the function. So this is the equation that we have for to find the curl of f. Okay, and we're calculating the 8a. So first, these are y, p, x, and q. What does that mean? So these are, this is q. Okay. So this means the partial derivative of f with the partial derivative of r with respect to y, and this means partial derivative of q with respect to z, partial derivative of r with respect to x, partial derivative of p with respect to z, and so on. I hope you guys understood it. Was just to explain the notation. Okay, so let's go ahead and find all these. So, and then plug these all together in this formula and calculate for a curl. Okay, so this is as simple as finding the pieces. So first we're finding the r of y, which means partial derivative of r with respect to y. So what is this r? So this is the function that we're given over here, right? So let's go ahead and rewrite this function so it's easier to see. So we have x squared sine of y z I hat plus z cosine of x z squared g hat plus y e to the 5 x y k hat. Okay, so this is the function that we have. So the I hat that you see here, it's always the p, and the g hat that you see over here, it's always the q, and the k hat, it's always the r. So this is how we do. This is how it's represented in the curl. So the I, j, k are treated as p, q, r. The functions p, q, r. So this is the function p, and this is how you're going to calculate the pz and py. First we need r, so let's go ahead and calculate r. Here we're going to find ry first. So ry, partial derivative of r with respect to y. So we are only differentiating y, which means x and z are treated as constants. Okay, so here you guys can see there is a y over here and there is a y over here as well. So this y is not a constant since we're differentiating with respect to y. So these are two different functions, y and e to the power of 5xy. So for two different functions together, we always use the product rule. Remember the product rule, which is f prime g plus g prime f. Then you have functions like f, g all together. Okay, so now here, let's write it over here. So we have our first function as f, which is y, and we have our second function as g, which is e to the 5xy. Okay, so what is f prime first? So f prime is 1, since we're differentiating with respect to y, right? We're differentiating with respect to y. And what is g prime? So g prime, it's the same thing. First of all, it's the same thing, e to the because it is like e to the 2x. So the derivative of e to 2x, e to the 2x, and then multiply by this inside function. So what is this inside function? 2x. And the derivative of 2x is 2. Okay, so the same thing over here. So this thing, the derivative of this thing, it's the same thing, and then multiply by this inside function that you see over here. So the inside function is 5xy, and we're differentiating with respect to y, so we only write the derivative of y. So the derivative of y is 1, and 5x stays over there since it's a constant. Okay, so now we can go ahead and plug this into the product rule formula and write it over here as our r of y result. So the r of y is f prime, which is 1, times g, which is e to the 5xy, and then we have plus g prime 5x e to the 5xy, and then we have f. So this is the answer to our y. Okay, so let's go ahead and find now qz. So partial derivative of q with respect to z. So this is the function q. We are calculating this with respect to z. Okay. So here again, you guys see this. You have z over here, and this you have this another function with z inside it. So this is the product rule again. So for this, let's do this over here. We are finding the product rule. So we have f as z, the first function, and g as cosine of x z squared. So now let's find f prime. So we have f prime as 1, g prime as, what's the derivative of cosine? So remember, the derivative of sine is cosine, and the derivative of cosine is negative sine. Okay. Okay, so here we have cosine, so the derivative of cosine is negative sine. Okay, so we can put negative sine. And of course, we're gonna put this as it is. And now this is a chain rule, so we'll need to multiply by the inside function as well. So what's this inside function? Xz squared. So let's multiply by this inside function, but the derivative of the inside function. Okay, so the derivative of xz squared, considering we're differentiating with respect to z, and x is a constant, so x is a constant, it's going to stay over there, and the derivative of 2z is z squared is 2z. Okay, now let's bring everything together as the f prime g plus g prime f. So we have f prime g plus g prime f. Okay, so this is for qz. Okay, I'm just gonna do it like this. So after, when I put this into the formula, it's easier for me to figure out where are the values. Okay, so this is ry. Let's put it in another color. Let's see. ry. This is qz. Okay. Now what do we have now? Now we need to find r of x. So the function r with respect to x. Okay. So we have this function r over here. We need to differentiate this with respect to x. So we have y e 5xy. So we have y e to the 5xy. We are differentiating this function with respect to x. That means y and z are constants over here. So this is a constant. Okay, it's gonna stay over there. Okay, and then here, this is the function, right? So the derivative of this function, it's gonna be the same thing. Okay, and then we need to multiply by this inside function, the derivative of the inside function. Now what's the derivative of inside function? this 5 and y are constant, so it's going to stay over there. The derivative of x is a 1. So this is the answer to this one. So just simplify it a little bit. So 5y squared to the 5xy. It's the value for r of x. Right? So this was the original function. Okay, so let's go ahead and write this as r of x. Okay, so we just calculated r of x. What do we need next? We need pz next. Function p with respect to z. Okay, the function p with respect to z. Now where is the function p over here? So we have function p as x squared sine of yz. Okay, so we have function p as x squared sine of yz. Right? It's correct, right? X squared sine of yz. Okay. Now, put it at the bottom a little bit. X and y are constant. We're differentiating only z. X is a constant. It's going to stay over there. And derivative of sine is cosine yz. Okay, the same thing. And then we need to multiply by this inside function. Okay, and y is a constant. It's going to stay over there. And derivative of z is 1. So this is the answer. It's going to be x squared y cosine yz is the answer for pz. This is our pz. Okay. Next, what do we have? We are left with qx minus py. So next, let's go ahead and do q of x. So we have this function q. We need to differentiate with respect to x. So where is our function q? So this is our function q, x cosine xz squared. Alright, so I just wrote the function q over here. So let's go ahead and find the derivative of this with respect to x. So that means x and y are constants. Sorry, z and y are constants. Okay, so here we have a z over here, so that's a constant. It's going to stay over there. The derivative of cosine is negative sine, like I explained before. And then we need to multiply by this inside function, the derivative of our inside function. So z squared is going to stay over there since it's a constant, and derivative of z is 1. So this is going to be negative z cubed sine of x z squared. And this is the value for qx. Now, what's our last step? So our last thing is to find p of y. Okay, p of y, the partial derivative of p with respect to y this time. We already calculated with respect to z. Let's find it with respect to y this time. So we have x squared sine of yz as our p. So this is our p. Let's go ahead and find this with respect to y. So with respect to y, again, x and z are constant. Okay, so x is a constant. It's going to stay over there. Derivative of sine is cosine yz. And here, the y and z. So this y, the derivative of y is 1, and z is a constant. It's going to stay over there. So we have x squared z cosine yz as the answer for py. Okay, now that we have everything that we need, let's go ahead and plug everything that we get into the formula of the curl, right? So where should I write it? Let's separate it and write it over here to the right. Okay, so I hope you guys can see it. If you can't, let me zoom in a little bit. The formula is here. So it's ry minus qx. So let me copy paste it and put it over there. Okay, so I just copy paste it over here. The curl formula. So let's go ahead and put everything together. So first we have ry. So we're putting ry at the first value. So already we calculated ry. So we have this value as our ry. So let's go ahead and put this over here. So we have e to the 5xy plus 5x e to the 5xy, and yeah, y again. And then we're gonna minus it with qz. Where's qz? So this is our value for qz. Okay, so let's go ahead and put it over here. So we have as cosine xz squared, and then we have minus 2xz squared because it's going to multiply each other, and then we have sine of xz squared. Sine of, wait, I don't know where have space. Okay, sine of xz squared. Okay, next we have negative j, so all this thing is I hat, and next we have negative j, and we need to put r of x. So we have r of x as 5y squared e to the 5xy, and next we have pz in the formula, so we're gonna go ahead and write negative pz. So negative, where is the pz? So pz, we have this here over here as x squared y cosine of yz, and then we have qx minus, okay, so k hat, and then we have q of x. So where is q of x? It's this thing over here. So let's go ahead and copy this from here and paste it over here. Okay, and at the end we have negative py, so py is this thing. So let's write that over here as well. So then we're gonna have this thing, negative x squared z cosine of yz. Okay, and this is our k hat then. So this is our equation of curl. This is the final answer to the equation of curl. I hope you can see this all. If you can't, let me just zoom in. Okay, so this is the equation of curl. It looks really big. You can see it all. Yeah. Okay, so now we have then the curl. Now we only have divergence left to calculate. So this is the last problem of this video. So 8b, compute the divergence of the vector field F. Okay, so in my channel, on the video find the curl and divergence, I have already explained you guys how to find the divergence of F. So if you're given a function F, so in order to find the divergence, what we do is we take the gradient and then we dot product it with the function F. Okay, so I'm just gonna go over a quick review over here. If you really want to learn and how to do it, then do watch this video. So just a quick review. So we take the gradient vector, the partial derivative of x, y, and z, and then we're gonna dot product it with the function PQR. So then we dot product it. This is the answer that we get. So we get Px, Qy, Rz. So this is the formula to find the divergence of F. Okay, so this is the formula that we have over here, and in order to find the divergence, what we need to do, we need to find the P of x. So that means partial derivative of P with respect to x, right? Partial derivative of Q with respect to y, and partial derivative of R with respect to z. And this is the function that we are given in the problem. So the first thing that you see over here, I hat, that's P, J hat corresponds to Q, and K hat corresponds to R, right? So P, Q, R. So now we're going to take the partial derivative of P with respect to x. Okay, so in the curl problem, we didn't find partial derivative of Q with respect to x. We found with respect to y. But not this. So these values are always missing in the curl value, the curl problem, so you will not find these in the curl equation. So let's go ahead and find partial derivative of P with respect Okay, so let's go ahead and find the p of x, so partial derivative of x, p with respect to x, so x and y and z are constant over here, so y and z we have over here, so this whole thing is a constant over here. So we're going to put it as it is since it's a constant and differentiate x only. So the derivative of x squared is 2x, 2x. Now, okay, let's write it all together. Okay, 2x sine of y z, since it's all together, it's constant. Okay, now q of y, we're finding q of y now. So partial derivative of q with respect to y, and you don't see any y over here, so that's a constant. This whole thing is a constant, and derivative of a constant is 0. And now finally the r of y, so the r of z, sorry, r with respect to z. So you do not see any z over here. So that means its whole thing is a constant, right? And since we have x and y is constant over here, so there's only x and y, that means this is 0 as well. So our divergent of f turns out to be then p of x, which is 2x sine of yz, and the rest we have as 0 and 0. So this is your final answer to divergence of f. Okay, I hope you guys found this video helpful, and if you guys want to solve more past midterms or anything, then let me know in the comments, and please do subscribe before leaving. Thanks for watching. Bye.